Okay, hello. Today we are going to review the midterm exam. In this midterm exam, by the way, I thought the questions were really easy, uh, but uh, but was not was not much difficult to grade. I worried if everyone get the right answer, then how can I grade? But I did not need to worry. So let's go from question number one. It's pretty simple, very simple question. It's simply, we have studied many times about this regression model with an intercept and two regressors. At that time, we considered x1 and x2, but now x2 is simply x1 squared. So it's pretty simple setup. And in addition, I'm giving you even easier structure of binary case. X is binary. In this case, in part A, X is either 0 and 1. In this case, it's simple. At end of the story, X equals to X squared. There is nothing more you need. Obvious multicollinearity. So obviously it's not identified. And also in the second part, in the second question, it is binary, but it takes two different values at 1 and 2. So pretty much the same structure, but I change it from 0 and 1 to 1 and 2. Then intuitively thinking, if A is not identified, B should not be identified. Just intuitively thinking, because, for example, say if you survey, so think about a survey, say, so for example, it's a yes or no question. Say, for example, are you employed now? Yes or no? The answer is yes or no. Then, like say in data A, yes is 0 and no is 1. That is data A. And in data B, yes is 2, no is 1. Then if one of them is identified but the other not, then something is not going right? You are having the same data, and just the difference is you are using different labels for different answers. Then and suddenly your data, your model is identified, then something is not going right. So that's the basic intuition. And then also more rigorously, we can show this. Like so, in part A, the simplest way to show it's not working is to show the equality. Two variables have a linear relationship between them, and then in the second equation, also the second variable, second regressor, can be expressed as a linear relationship, linear combination of first regressor and intercept multiplied by something, right? So obvious multicollinearity again, which also simply proves the non-identifiability. That's what I wanted. So I enjoy making questions, and my goal is to make a question that is very simple to answer if you understand it correctly. But it won't be easy to answer if you just do not understand what's going on. And so the ideal answer would be two lines like this. This is it, right? But okay, if I understand, also it is reasonable. Like I do not expect you to have this answer in the exam, but if you try to uh, show non-identifiability in a different way, then there are two other ways to do that, like calculating the determinant, calculating the full rank condition directly. So in this case, the problem is, say, Ahmad considered this matrix. This is right. This is correct. This is what you had to do. You have to calculate expected value of 3 by 3 matrix, and then you have to calculate its determinant. You have to, like what Ahmad did is, so he calculated the expectations. It should be right, but it's correct. But why? He did not explain why. So I don't like that part. I ask you to explain every step of your argument. If you just get to here, there is just one more step you have to do. That's to calculate the determinant. If you Google, there are ways you can calculate the determinant of 3 by 3 matrix. That's possible. You can learn how to do that, but that's not a good idea. But the approach that I recommend is to demean the variables. Just remove the mean, make everything mean 0, and then it becomes 2 by 2 matrix. And 2 by 2 matrix determinant is much easier to calculate. And this has been what our approach in this class, in the homework, and like in all the classes. So then you will get, anyhow, the determinant equal to 0. But this is incomplete. 3 by 3 matrix, and then you have to show the determinant. Another way to show non-identifiability is to show observational equivalence. Observational equivalence can be considered this way. Just simply speaking, and I'm just calculating I'm just showing you the intuition. From the data when x is binary, what we can calculate, basically all the information can be summarized by these two numbers, conditional expectations. So for those who said yes and no, you calculate the expected conditional expectation, and then the first group has this, and the second group has this. You have only two groups and their outcomes, and from each group you can calculate the average of the outcome, and then from two groups you have to identify 3 parameters, which is not possible. That's the intuition, but intuition is not rigorous. That's just so you have to guess the answer first and then make up your step-by-step argument. And then what you can tell here is you can identify alpha plus beta plus gamma from the first group, and then you can identify beta plus 3 times gamma by the difference, from the difference between those two groups. That's all you can identify. And that means you cannot distinguish, say for example, beta, if the difference was 10, for example, then this is 10. But it equals to 10, but it does not say what is beta and what is gamma. So for example, beta could be 10, but gamma is 0. Or beta equals to 0, but gamma is 10 over 3. So we cannot tell what is what. There are infinite number of combinations between beta and gamma that satisfy the equation. So you cannot tell. So that's the basic intuition. And Hyunwoo did used that idea to show this, but he made a algebraic mistake. So, but approach is correct. I understand what he wanted to do. This is correct, but some mistake. I guess it was a mistake. Something is not correct. That was question number 1. It should have been super easy and very intuitive, very, very simple case, but was not that hard to you. Okay, let me do question number 2 in the next video.